Here we're going to look at series reaction and how selectivity changes with reaction time. Lots of reactors have multiple reactions, and for the series reactions, often the case that this product B is the desired product. And so the most important variable then is reaction time. Now we've defined selectivity before, and we can look at a couple selectivities. The instantaneous selectivity is the rate of B formation over the rate of C. And if, let's assume these are two first order reactions, so the rate of B formation would be K1 concentration of A minus K2 concentration of B over K2 concentration of B. Well, this is not going to be a very useful selectivity term, because you can see as reaction proceeds, this term can become larger than this term. So selectivity to be negative would not be as useful term. So instead, let's look at the overall selectivity. And this, for example, for a flow reactor, it'd be the flow rate of B over the flow rate of C, which would then be the volumetric flow rate times the concentration of B, volumetric flow rate. So this would be concentration of B, concentration of C. And that would be for a flow reactor. Well, it turns out for something like a batch reactor, it's identical, because the selectivity for a batch reactor would be number moles of B at any given time over number moles of C. And that's related to the volume of the reactor contents over the concentrations. And so batch and flow, if we're looking at plug flow, they're going to have identical behavior. CSTR, of course, will be different. So if we look at what the selectivity looks like, and we'll just look at a plot. So we can see here as reaction time, whether it's in a plug flow reactor or a batch reactor, as reaction proceeds and the concentration of A decreases, concentration of B increases, but then the concentration of C is also increasing. And so if we look at the selectivity, we're going to see selectivity is decreasing as reaction time increases. And so if I were to plot for data shown here in a batch reactor, let me plot the selectivity, overall selectivity. And you can see the selectivity decreases with time. At very short time, selectivity is very high, but of course we don't have much product, so that's not going to be a very useful condition. And also the actual separation of that product would be difficult. At longer times, our selectivity is significantly lower, and so what condition we'd run a reactor at depends on economics of the overall process. But you can see the most important variable for series reaction selectivity is reaction time.